Well, you feel like there's been a lot of negativity the last few slides, just negatives all over the place. So I want to do a little review of negatives and what happens. So what you would have noticed is it seemed that a negative exponent on the bottom would bring this to the numerator, and if you got a negative in the numerator, it would bring it to the denominator, and magically all the negatives went away. Okay. Question is why? Why does that work? And I want to show you why. So if I have this, to get rid of a negative exponent, first thing I do is I make the bases fractions, because then I can flip the fractions. If that's a negative. Right, so I can flip the fractions. And then I can do this. So 1 cubed over x cubed, 1 squared over y squared, and I get that. Right? But then, because fraction bars represent division, right? So if we come over here, oops, right over there like that, okay? We could say 1 over x cubed divided by, because the fraction bar is division, 1 over y squared. And that equals 1 over x cubed times division. Remember, way back to division of fractions, you have to flip it to multiply, times y squared over 1. Multiplication of fractions, 1 times y squared is y squared. 1 times x cubed, or x cubed times 1, is x cubed. And what you'll notice is this answer here is the same as that answer there. Okay? So you can do all this work. You'll never need to do all that work on an assignment, test, or quiz, or exam, or anything. But you could do all this work to get the exact same answer. Or you could say, anytime I have a fraction, negative exponents go to the bottom to make them positive. If negative exponents are already in the bottom in the denominator, they move to the top to make them positive. And that's a real shortcut, and that's what they were doing that you saw in the solutions here. They were taking shortcuts to get there. Let's try one more. I want to make sure you don't miss something. Hang on here. The red kind of stayed there on me. Okay, let's try one more. What if I had something like this? 3 over, we'll use u to the 4th, to the negative 4th. Okay? That's going to equal 3u to the positive 4. Right? Because the 3's in the numerator does not have a negative exponent. It does not go anywhere. It stays in the numerator. This has a negative exponent in the denominator. We move it up to the numerator to make it positive. So leaving us with a denominator of only 1, right? Because this had to move up to the numerator to make it positive. But then we never have to show the 1 when the denominator is 1, so we get 3u to the 4th. Okay? So you just have to be careful, follow the rules. There's always a little variety there. Right? What if, and I'm going to change this one just slightly, 3 and 2u to the negative 4. Okay? Now, this is 3u to the 4th over 2. Okay? And what happens is this here has a negative exponent, right? This 2 does not have a negative exponent. If the 2 had a negative exponent, that would be in brackets, but it's not. So that negative exponent just applies to the u. So the u to the negative 4 goes to the numerator to become positive. The 2 was in the denominator. The 2 stays in the denominator. So those are things you gotta be careful, kind of little tricks to look at or little things where you're careful in the rule. If I had this 3 over 2u in brackets to the -4, this one's different than that, right? So now the entire 2u is the base, not just the u. So in this case, we'd have 3, and then we'd have 2u to the 4th, and nothing would be in the denominator, so we'd use a 1. Okay. But we don't really need the 1, so we don't actually need to show this at all. We don't really need to show that. But then that would not be done. This would be 3, 2 to the 4th, u to the 4th, which would equal 3 times 16 times u to the 4th, which would equal 48 u to the 4th. Okay. So you have to be careful, right, if the negative exponent applies to just the variable or to the variable with the coefficient, with the number in front. Okay. Lots of little pieces with exponents. Just takes practice and you will get there.